This is part 7 of square roots and radicals. I'm going to do a little bit on multiplying square roots again, where we might have a little bit larger numbers. So we're going to use this property. If a is greater than or equal to 0 and b is greater than or equal to 0, then the square root of a times the square root of b equals square root of ab. We can use that, but sometimes it's easier not to actually multiply a times b. Here's an example. Square root of 21 times square root of 14. I could go ahead and multiply those two numbers together, but I get kind of a large number, and then it's actually going to be harder to figure out what the perfect square factor of that larger number is. So instead, when you see that you're multiplying two numbers, look and see if there's a common factor in each of them. And 7 goes into both numbers. So how about if I write 21 as 3 times 7? So notice I'm putting the common factor as the second factor. And then for 14, that's 7 times 2. This time I'm putting the 7 first. And the reason is so I can see those two 7s right next to each other. Well, that means I've got a perfect square in that, the 7 times 7, which I could bring out. And so my answer is 7, that's on the outside, and 3 times 2 is 6. Now, you would have gotten the same answer if you multiplied 21 times 14 and then factored it as 49 times 6, okay? Or by prime factoring it and getting 3 times 7 times 7 times 2. It's just that why do that extra arithmetic if it's not necessary? All right, let's do another problem. All right, square root of 35 times the square root of 55. Can you figure out the common factor for both of those? 5. So I'm going to write 35 as 7 times 5, and 55 is 5 times 11. And that way I can see I've got two factors of 5, so a 5 pops out, right? That's the square root of 5 times 5. So 5 comes out, and what's left inside is 7 times 11, which is 77. So you see how that's working? This also works if you have something with variables. For instance, square root of 22x cubed, so the square root of 22x cubed times the square root of 33x. So first I'm going to deal with the number parts. So the common factor in both 22 and 33 is 11. So how about I write 22 is 2 times 11, and 33 is 11 times 3. And now I've got x cubed times x. That'll give me an x to the 4th, which is a perfect square. So what can I do here? I could take out 11 times 11. That means that 11 pops out. And for x to the 4th, an x squared pops out. So that gives me on the outside 11x squared times the square root of 2 times 3 is 6. All right, what about if we had square root of 6x cubed times the square root of 2x, let's see, to the 5th, times the square root of about 5x to the 7th. Okay? All right, so what do I have here? I've got for the numbers 6 times 2 times 5. I'm looking to see if any of them have a common factor. And well, between the 6 and the 2, I see it. So how about I rewrite it? The 6 is 3 times 2. Then I have that 2, and I've also got the 5. All right, so I can see at least I'm going to be able to pull a 2 out. Now, what about all the x's? I've got x cubed times x to the 5th times x to the 7th. So remember you add exponents? Well, that's going to give you x to the 15th. But that's not a perfect square. So the trick is to say, well, I know it's x to the 15th. I want to write that as x to the 14th times x, so I can pull out this perfect square. So from both of those 2's, I get to pull out a 2, and the square root of x to the 14th is x to the 7th. So therefore, on the outside I have 2x to the 7th. On the inside I've got 3 times 5 times x. That's 15x. How about this one? 12x cubed, the square root of 12x cubed times the square root of 3x. So with the numbers, now if you want you could just go ahead and do 12 times 3 and get square root of 36. That's perfectly fine. Or you could do it that factoring method I've been doing. I'm going to just do 36 because 12 times 3 is so simple. And how about x cubed times x? That'll give me x to the 4th. So let's see, these both are perfect squares. So a 6 comes out and an x squared comes out. And here's the trick. Remember, if everything comes out, there's just 6x squared. You don't really see it, but there's kind of like an invisible 1 in here if you want. So it's not like there's nothing, but the square root of 1 is 1. So you would have 6x squared times 1, which is just still 6x squared. Now, you could have done this 12x cubed. You could have written that as, you said, well, between 12 and 3, there's a factor of 3, right? So you might have written it as 4 times 3 times that other 3, and the x to the 4th. And then hopefully you'll notice that the square root of 4 is 2. Here's 2 3s, so I could take out a 3. And from x to the 4th, I could take out an x squared. Notice you're still going to get that 6x squared. What about if you have a number in front, like negative 3 x squared square root of 10 times 5 square root of 30. Okay. Well, as usual, the numbers outside in front of the square roots get multiplied together. So I have the negative 3 times 5, negative 15x squared. And now we have to deal with what's inside the square root. And again, you could just do 10 times 30 and then figure out what the perfect square is in there. Or I could say, what's the common factor? And it's 10, right? So 10 I'm just going to keep as 10. And 30 I'm going to write as 10 times 3. So I could take out from these two 10s, 1 10. And on the outside I have negative 15 times 10, so it's negative 150 x squared. And this time I'm left with the square root of 3. You're thinking, good grief, does it ever end? Well, not really. There's just all sorts of problems that could come up, and so you've got more than one way of coming up with the answer, and this is a trick to making your arithmetic easier.